Autumn brings longer and darker nights for skywatchers, as well as a bonus, an upswing in meteors, the bright and transitory trails of tiny particles that burn up as they plunge into Earth's atmosphere at tremendous speed. Between late September and early January every year, Earth's orbit carries us through a series of debris fields left by passing comets, producing meteor showers for skywatchers to enjoy. It all kicks off this weekend with the peak of the Orionid meteor shower. Every shower has unique characteristics, some are stronger than others, some include fireballs, and others feature long, persistent trails. While the showers recur every year, moonlight can make or break a meteor shower for skywatchers. Finding the ideal viewing location and knowing where and when to look will increase the number of meteors you see. In this edition of Mobile Astronomy, we'll focus on meteors, how you can use mobile apps to predict the best showers, tips for seeing them, and what to look for. How to see the best meteor showers of 2017. Meteor shower basics. Many people use the phrase shooting star to refer to streaks of light across the sky caused by meteors, but that terminology is misleading. The phenomenon happens right here at home in our solar system, completely independent of the distant background stars. These flashes of light occur in Earth's atmosphere. Meteor showers happen when Earth's orbit carries our planet through zones of debris left in interplanetary space by periodic comets and some asteroids. Over centuries or longer, the 1 to 2 gram particles released by the orbiting body, which typically range in size from sand grains to small pebbles, accumulate and spread out into an elongated cloud along its orbit. The debris is analogous to the material tossed out of a dump truck as it rattles along. The roadway gets pretty dirty if the truck drives the same route many times. If Earth's orbit intersects the comet's orbit, we experience a meteor shower that repeats annually because Earth returns to the same location in space on the same dates every year. As we traverse the cloud, our planet's gravity attracts the particles, and they burn up as shooting stars while falling through Earth's atmosphere. The particles can enter at speeds of 25,000 to 160,000 miles per hour, 40,000 to 256,000 kilometers per hour, and the kinetic energy of each particle ionizes the air molecules it encounters, leaving a long trail of glowing gas that is less than a few feet wide but many miles long. Most trails occur in the thermosphere, the region of the atmosphere situated between about 50 miles and 75 miles, 80 to 120 kilometers, above the ground. Slower meteors need to reach the denser atmosphere at lower altitudes before forming a trail. As viewed from Earth's surface on a clear, dark night, these trails glow briefly as they streak in front of the distant stars. The colors that meteor watchers see come from a combination of factors. Red light is emitted by the glowing air molecules. Meteor material itself is burned up during its high-speed passage. Oranges, yellows, blues, greens, and violets are produced when minerals, such as sodium, iron, and magnesium, in the particles are vaporized. Scientists can analyze the spectrum of color in a meteor trail to determine the composition of the material. If anything makes it to the ground, it becomes a meteorite. An easy way to remember the difference is to recall that many rock names end with "ite", like granite. The duration of a meteor shower depends on the width of the zone, that is, how many days or hours it takes Earth to pass through it. A meteor shower commences on the date when Earth first enters the debris field. The shower then builds to a peak when Earth passes through the densest portion of the cloud and then tapers off, ending on the date when the planet exits the zone. The number of meteors produced during a shower depends on whether Earth passes through the densest region or merely skirts the edges. Because the debris is also orbiting the Sun, the clouds vary in density on a timescale related to the source comet's orbital period, producing years when more or less material is encountered. Planetary scientists create models of the debris distribution to help predict the intensity of showers each year. Apps designed for meteor shower observing often take the variations into account. How meteor showers work. Infographic. The inherent brightness of the meteors is dictated by the average size of the grains in the cloud. Some showers are known for having fewer but brighter meteors, while others are dimmer but much more prolific. Most showers are global events, but certain showers are better for observers in either the northern hemisphere or southern hemisphere depending on whether Earth is riding high or low through the cloud. During a shower, meteors can appear anywhere in the sky, but all of the meteors from that shower will be traveling away from a particular part of the sky, called the radiant. This point always lies within the constellation that gives the shower its name, Orion for the Orionids, Perseus for the Perseids, and so on. The radiant simply marks the direction in the sky that Earth is heading toward while the planet is traversing the debris cloud. This rule can be broken when two showers occur at the same time, and also by random meteors, called sporadics, which aren't part of the main debris field.